This is very important lecture uh, in terms of increasing the accuracy of the method. For the time being, we are looking at the different methods, what they have different positives and negatives as well. They have advantages and disadvantages. So, if you just go back and talk about the average, so what we discuss, we actually have Q and I 1 over delta xi minus 1 half to xi plus 1 half q x t n dx. This was the average that we discussed in finite volume method. And this q, when replaced with, if q is replaced with some q tilde, which Godunov's proposed, then we have a first order upwind method. Instead of just replacing with q tilde, which has a constant value, let Godunov's proposed that why not add a linear piecewise polynomial. Piecewise polynomial. So what we have an option over here. So we can replace q tilde with q tilde x t n is equal to the value of qn. He proposed that put only qni. But here, what we do, we add a slope, sigma. Sigma is a slope at cell number I and x minus xi, where x is from xi minus 1 half to xi plus 1 half. We know that from the calculus, the equation of straight line is y minus y1 m x minus x1. Here, then we can write, for example, y1 m x minus x1. Here the y1 is qni and m is sigma ni, since we need a slope at each cell, and x is the unknown, and xi is the value at cell number I, and we will talk of. So it just corresponds to, this corresponds to the equation of straight line over here. So we need to define, for example, if we have xi minus 1 half and xi plus 1 half, and this is cell number I, and this is basically xi, this is xi minus 1 half. The value of xi can be obtained by the average formula, xi plus 1 half, xi minus 1 half divided by 2. This xi can be put it over here. And delta x, if delta x is required, the delta x will be equal to xi plus 1 half minus xi minus 1 half. Since it is a difference between two faces, this is delta x. Okay, we know that from Riemann problem, the value, the new value n en plus 1 can be obtained by just taking x minus u bar delta t tn. The new value should be equal to the x minus u bar delta t, which is a characteristic, which is a characteristic. So let me just here I just repeat plus u bar partial q by partial x0. Let me just review what we have earlier. When the initial condition is given as sine x and u bar is greater than 0, then we have uxt will be equal to sine x minus u bar t. That's what we have as a solution. So the numerical method should follow this solution, the value of q at characteristic. When we put q tilde n into the equation, q tilde n into the equation, we get qn plus 1. We have qn plus 1 u bar delta t by delta x qn minus 1 plus 1 by 2 delta x minus u bar delta t and sigma ni minus 1 plus 1 minus u bar delta t by delta x qni minus 1 by 2 u bar delta t sigma ni. This will be the formula for higher order or maybe different order than the previous one, which changes with the values of slopes. Here you can see the slopes, all the slopes. So suppose when we have zero slope, sigma ni is equal to 0, then we have qn plus 1 u bar delta t by delta x qni minus 1. This will be equal to 0. This is 0 plus 1 minus u bar delta t by delta x, and this is 0, so we have qni. It should be plus this value should look like this, and this should be qni. Okay, so when we solve that, u bar delta t by delta x qni minus 1 plus qni minus u bar delta t by delta x qni. Maybe I missed something over here. Let me see. qni. Okay, no, this is fine. qn plus 1 qni plus u bar delta t by delta x take as a common qni minus 1 minus qni. This is the upwind method. So you can see that when q tilde was equal to constant value, q was a constant, then we have a upwind method. When we have a piecewise polynomial, why we need piecewise polynomial? The reason is we have different cells. In each cell we define different line. That's why it is called piecewise polynomial. So you can learn that the qni minus 1/2 sigma ni minus 1/2 and sigma ni are the slopes, which changes the method. So for the slope we have different formulas. For sigma ni, when we put sigma ni at cell I, the slope, if we take a slope qni plus 1 minus qni minus 1 divided by 2 delta x. When we have sigma ni and qni minus 1 divided by delta x, and sigma ni if it is forward difference qni divided by delta x. This method will be the from method. From method, this will be our beam warming method. When we put this sigma and I into the previous equation in here, over here, then we get beam warming method. I recommend you to put these values and find out the method form yourself. And for this, we have, for example, Lex-Wendorf method. Lex-Wendorf method. So these are the different slope choices. We call it choices of slopes. So this was all about the piecewise linear reconstruction of Godunov's method. Thank you for watching.